So welcome to this video. So in this video we're gonna be solving a competition problem. So here goes the competition problem. So we'll be given an array and we have to find whether there exists any duplicate number in the given array. If so, we have to return that duplicate number, and if not, we have to return a value 1. Yeah, so that is the overview of the competition problem. So basically the array will only contain positive numbers, so and it will be in the range of 1 to n. So the array will contain a total of n plus 1 elements, and one element will be duplicated multiple times, and all the other elements will be distinct, so they won't be duplicated. Yeah, so that is what about the problem statement. So if we observe these 4 examples, let us go through these examples one by one such that we will understand the problem statement better. So in the first example, we have an array of elements 1, 3, and 3, 4, 2, and 5. So here this is an array of length 6, and we have elements starting from 1 to 5 with one element 3 duplicating twice. So we will be writing an output 3. And in the second example, the element with value 5 is duplicating, so we will return 5. And in the third example, the element with value 6 is duplicating, we will return 6. And in the last example, the element with the value 7 is duplicated, so we will be returning an output of 7. So this is the what problem statement is all about. We should return the duplicate element. So let us go through all the different approaches which we can use in order to solve this problem. So first we'll go through a brute force approach. So in this approach, we'll go through all the possible pairs in the give, which can be possible from the given array, and we'll check whether there exists any pair whose values are the same. So for that, we'll be running 2 loops. So basically, we'll be running 2 inner loops in order to traverse through all possible pairs of this given array. And inside the loop, we'll be checking whether the values of the elements of the pair are equal or not. If it is so, we'll be returning that particular value of the element. If not, we'll be at the end we'll be returning 0. So this is what the algorithm is about. So this is the computer program, so which is written in Java programming language. So here, as we have discussed, have initialized 2 loops, and inner loops. So one is starting from index 0 all the way to the last index, and other um, index is starting from I plus 1 till the last index, such that for index 1 we'll go all the way from 1th index to the last index, and when I is at the last index, in this case it is n. So since j will become n plus 1, so since n plus 1 is less than n, we won't go inside. So we'll go through all possible pairs of this given array, and we'll be checking if there exists any pair whose values are same. So if so, we'll be returning that value. So in this approach, the time complexity in terms of big O notation will be like big O of n square, because since we have been going through all the possible pairs, so the worst time complexity of this algorithm will be in this scenario when the duplicate elements are the last element and the last button element. In that case, we have to complete the many iterations in order to get in order to find the pair who in order to find whether there exists any duplicate or not, because when we start from index 0, we have to go all the way from index 1 to last index, so which it makes us to execute this inner program n times. And when we start in index 1, we have to go all the way from 2 to index n. We have to travel, we have the program will be running n minus 1 time. And when we are at index, when we start at the last but one index, we'll only have to traverse, will this index inner program will be only executed one time. So this is the number of times this inner program will get executed, so which will be equal to n square by 2 plus n by 2, so which is approximated as big of n square time complexity. So if we talk about space complexity, so since we are not populating any data structure over here, so that the space complexity will be a constant. It will be big of 1. So this is what is about the brute force approach, where we have been checking all the, where we have been going through all the possible pairs of the given array and checking whether there exists any pair whose values are same or not. If so, we'll be returning. If not, at the end, we'll be returning 0. We shall see the second approach, or where we have been using hash set in order to determine whether there exists any duplicate in a given array or not. So here, first we'll start traversing through the elements of the given array, and we'll be adding the element which we are currently at to the hash set if the element is not in the hash set already, and if it is so, we'll be returning that number. So it is that simple. So this is the algorithm which we use in this approach. So let us see the computer program for this algorithm. So this computer program over here is as well is written in Java programming language. So this has a method called file duplicate, which takes an input as an array of integers. And in the first line, I have initialized an hash set, and then I have started looping through the elements of the given array nums, and I have been adding the element of the array to this hash set listed. So basically, this add method of the hash set will return true if the element is not present in the hash set already. If it is already present in the hash set, it will return false. Yeah. So only when we encounter a duplicate number, so this will be returning a value true, and we'll be going through the find first, and we'll be returning this value n. So otherwise, since this or else will be only executed at the end of all elements of this string gets executed, so at the end we'll be returning 0. And if in between, if this condition ever becomes true, when this add method return false, it does so when we already have this element n in the hash set. So it will be returning the value n. If not, at the end, we'll be returning the value 0. So this is what the computer program for this algorithm is all about. So if we discuss the time complexity and space complexity of this algorithm, so in this case, the first case time complexity, or the time complexity in big O notation, will be big of n. This is because in this case the number of iterations will be n. I mean, suppose if the if we have one element which is appearing twice in a given array. So suppose if it is at index I and the second element duplicate is at index k, so the number of iterations which you have to do is the k times. So since the duplicate is at index I and then index k, so we have to go through k indexes. We have to run the loop for k indexes in order to find the uh, in order to check whether there exists any duplicate or not. So in this case, the worst case time complexity will be in a scenario when one of the duplicate element is in the last element of the given array. So in that case, we have to go through this loop will be running n times, n times. So n being the length of array minus 1. So that's being said, we can say that the time complexity will be big of n. So if we check the space complexity, so here as well, the worst case space complexity will be in the scenario when one of the duplicate elements is in the last portion. So in this case, the hash set will be populating, will get populated every time. So it will get populated, it will be populated n minus 1 times. So we can say that the space complexity in big of notation is big of n. Yeah, so this is what is about the second approach. In the second approach, we have saw a decrease in space time complexity, but the space complexity is not a constant. It is a linear space complexity big of n. Now we'll see approach 3 and followed by approach 4. These are the two approaches through which we can solve the same problem as the above problem. So in this approach, basically we will start traversing the given array, and along with manipulating the element of the visited element in order to store the information of how many times that element that the value in the element is present. So while manipulating it, we have to make sure that we don't actually lose the actual contents of the element of the array. So that being said, that is the overview of this algorithm. Let us go into in detail. So first, we'll be traversing the given array. So we have discussed we have an array of length n plus 5 and the numbers being in the range I to n. So first we'll start traversing the given array. So when we have been traversing, for each element at index I, we'll be adding an value of n plus 1 to the element at index I. For suppose when we have, let me just explain clearly. For suppose when we have been traversing the array, if we found an element with value I, we'll go to the element at index I and add a value n plus 1 to that element. So since we are modifying the elements by adding n plus 1 to the values of the elements, so when we are checking uh, um, the value would have already been altered, right? So in order to get the original value before the addition, we'll do the remainder of the value present at the element by dividing the value at the element with the value n plus 1. So this gives us the remainder. So this gives us the original value before adding n plus 1s. So the remainder will be basically if we are at index I, so we have to check the value remainder of element at index I and the value n plus 1. So the remainder will be basically of 1, which is the value of at index I minus n plus 1 times x. So x being the number of times n plus 1 has been added. So this leaves us the original value before doing any addition n plus 1. So this is the first step or first phase where we traverse through the elements. So we'll traverse to the elements. So we do the modification of the element. So suppose if we encounter a value I, we'll go to the element at index I and add a value n plus 1. So since we have been modifying the elements of the given array, we can't directly go to index I. So we have to divide the index, get the remainder of value at index I by dividing it with the value n plus 1, since we have been adding n plus 1. So to get the original value before doing an addition. So after this traversal, we'll be doing one more loop. So in this loop, we'll be traversing all the way from first element, and while we have been traversing, we'll in this case we'll find the quotient of the value present at element with the value n plus 1. So for suppose if we have been in this traversal, if we are at index I, so we'll be getting the quotient of element at index I and the value n plus 1, so which gives us the quotient. For suppose if we have added n plus 1 two times to the value at index I, so the quotient will be 2, so which says that the n plus 1 has been added twice. It means that there are two elements with value 1 in the given array. So we'll be returning that array. So this is the computer program, sorry, this is the algorithm for this approach. So basically we have manipulated the elements of the given array in order to store how many times an element has been present in the given array. And we have, after manipulating, we have done another traversal in order to check how many times an element has been present in the given array, and if it is present twice, we'll be returning um, true. We'll be returning that element. So since it might not be twice, it might be thrice, or might be 4 times as well. So we'll be just checking if it is greater than 1. If appearance is greater than 1, we'll be returning that element. So this is the computer program for the discussed algorithm. So this computer program as well has been written in Java programming language. Over here we can see we have a method called find duplicate, which takes an input as array of integers. So this basically solves is the computer program for this discussed algorithm. Over here first I have been getting the length of the given array. So this gives us the, suppose we have an element starting from I to 1 to n in the given number. So the array length will be n plus 1. So then we will start looping through the given array, and when we start looping through it, first we'll get the remainder of the value and the value L being the length of the given array, and then we'll add a value n plus 1 to the element at index original value given by this remainder. So for suppose if this value is j, so we'll add a n plus 1 to the element at index j. So at the end of this loop, an element at index I will have been added n plus 1 values as many times as the value I present is in the given array. So at the end, now we'll be starting another loop where we start traversing from the first element all the way to the last element. And over here, we'll be checking the quotient of the value present at index I with the value n plus 1. So the no element in the given array will be of value L, because the elements will be only ranging from I to n, 1 to n. So n being the n plus 1 being the length of the given array. So that being said, when we get an quotient which is greater than 1, we'll be returning it. So this is computer program. So for this algorithm over here, we have used the streams in order to solve this problem. Without using streams, we can use the normal for each loops as well. So this computer program does the same, but it is written in a bit different manner. So here we have an for each loop, where we have been traversing through the nums array, and we have been getting the original value by getting the remainder of value, and the value L being the length of the number, and we have been adding a value L to the element at index, this original value, and then we have been starting a loop again. We have been getting the quotient. If quotient is greater than 1, we will be returning that integer. If not, at the end we will be returning 0. So that being said, this is the computer program for this algorithm. So where we have manipulated the values of a given array without actually losing the original contents of the elements of the given array. And then again traversing the given array to find how many times an element is present in the given array. So if you observe the time complexity of this algorithm, so the worst case time complexity in this scenario where duplicate element is at the in last index. In this scenario, we have to, in the first loop, we'll have to go definitely we have to go through all the elements of the given array. And in the second approach, so since the duplicate numbers uh, is at the last index, for suppose the duplicate number is n, and it is present at n minus 1 index, it means that uh, the n plus 1 will get added to the last element itself twice. So we have to go through all the way to last element in order to get the value, in order to find the check, in order to identify that the last element is the duplicate element. And in the second approach, sorry, in if we talk about space complexity, the space complexity is like big of 1, it is a constant. Over here, since we have not populating any data structure, so it means that we are not creating any additional data. So it means that a space complexity is constant, it is big of 1. So in the final approach, it is a fast and slow pointers algorithm. So first, let us discuss the algorithm. So we'll start with 2 pointers. Let us name it as tortoise and hare. So initially, both pointers will start from the first element of the array, and we'll start moving the hare pointer 2 steps at a time, and tortoise pointer 1 step at a time. So during this traversal, the tortoise pointer and hare pointer will meet at a point. So when the both elements meet at a point, we'll stop the loop. We'll stop the traversal of hare pointer and tortoise pointer, and then we'll move one of the pointer, either hare pointer or a tortoise pointer, to the first element of the array, and keep the other at the intersection point. And now we'll move both pointers 1 step at a time. So in this case, when both pointers meet, so it will be the entrance point of the cycle. So which will be the duplicate number as well. So that is the algorithm for this slow pointers, fast and slow, in this fourth approach, which is fast and slow pointers algorithm. Or here, when we start traversing the given array, so by the value presented index, by the value presented in element. So when we are at element index 0, so we'll next go to the index as per the value present at index 0. So if in the element at index 0 has value 2, we'll go to index 2. So when we do that, so since the indexes which we have been traversing repeats in a cycle, we are using this fast and slow pointers algorithm. It means that when we are when we traversing through this given array, so we will go through the same index again. So it means that we'll be in a cycle. So in order to detect this cycle, we are using the fast and slow pointers algorithm. And also along with that, in order to find the entrance of the cycle, we are using the fast and slow pointer algorithm. In this case, the entrance of this cycle happens to be the duplicate number which we are looking for. So, so that is why we are using the fast and slow pointers algorithm. So before checking the computer program for this algorithm, so let me just explain these questions which you might have in mind as of now. So the first question is why will be stuck in a cycle when we start moving to the index as per the value of a element, and why the entrance to the cycle is a duplicate number. So let me just answer these two questions. So if we understood this properly, you'll have a clear understanding of this algorithm. So assume an example where we have an array of length n plus 1 and having distinct elements which is ranging from 0 to n. So now if we start traversing the array and moving to the index as per the value of an element, we'll end up in a cycle. So basically an index starts when we reach an element whose value is already an index which we have which we have already visited. So that will be the end point and the entrance point of an cycle. So let us check out this example. Over here I have an array which is of length 5 and has elements ranging from 0 to 4. So when we start at index 0, which has value 4, the next we'll go through the index 4, which has value 3, and next we'll go through index 3, which has value 0. So we are constantly in a uh, loop with the element at index 0, 3, and 4. So this means that when we have an array of length n plus 1, which have distinct elements ranging from 0 to n, and when we start traversing to the index as the value of an element, we'll end up in a cycle. So for suppose if we reach an element, in order to reach an element at index p again, we have to come to its previous index j, which has value p again. So in order to reach index I again, we have to reach its previous index first, which has a value I. So and it goes on until we reach the first previous index again. So when we reach the first previous index again, um, we will enter a cycle. So since we didn't have any duplicates, so in order to reach the previous index again, we have to reach uh, the first previous index will be the 0 because it is the index which we definitely traverse. So 0 is the entrance of the cycle. So if we ever reach an element which has a value 0, it means that we have just completed an iteration of a cycle and we have entered the second iteration. Yeah. So that being said, let us take a different example. So here we have an array which has of length n plus 1, which have elements whose values are ranging between 1 to n. 1 and n is inclusive, with one integer with one value being repeating itself multiple times. So now, if we start traversing the elements of the given array, and if we start traversing to the index as the value, move to the index as the value of an element, we'll end up in a cycle. So during this traversal, first we'll go through these distinct indexes until as long as we are going through the elements whose values are the indexes which we have not been to. But when we reach an element whose value is an index which we have already been to, it means that we are looping through a cycle. So in this case, in the second case where we have an array whose values are ranging from 1 to n, we don't have any element with value 0. So a cycle is not possible with index 0. So in order to loop through a cycle, or in order to reach an element at index p again, we have to reach its previous index, who which is an element whose value is p. So we have to reach that previous index I again, which has a value p. And in order to do that, we have to reach the its previous index j, which has a value I, and it goes on until and it starts when we reach the first previous index. So the first previous index is possible in this case when we have a duplicate element. So for suppose if we have two elements which are index I and j, which both have values k. So if we have reached index I, so from index I, since it has a value k, we will go through the index k, element at index k. Now in future, if we have ever been to index j, since the element at index j also has a value k, we'll go through the same indexes again. Since we have been going to index k again, from index k we'll go to the same index. So it means that we are in a cycle, and the entrance and the endpoint of this cycle is element at index j. So that being said, that the duplicate number is a entrance point of this cycle. So now you should have a better understanding of why we'll be stuck in a cycle when we move to the indexes as per the value of an element. So, and why the entrance of the cycle is an duplicate element. So this gives a clear understanding of phase 1. And now in the phase 2, we have said that we'll move one pointer to the first element of the array, and second pointer will leave at the intersection point, and we'll move both pointers one step at a time, and both pointers will meet at the entrance point of the cycle. So how can we justify this? So to justify this, let us take this example. So in this case, we have an elements ranging from 1 to n. N is the number of distinct values in the given range 1 to n. And let us suppose d, the value d is a duplicate number, and capital F, is the distance between first element of the array to the start of the cycle, and c is the length of the cycle, and x is the distance between start of the cycle and the intersection point within the cycle, the first intersection point. And k being we have discussed that the hair pointer and tortoise pointer will meet, right? So the k is the number of cycles completed by hair before the tortoise and hair pointers meet. So in the first phase, we'll be moving tortoise pointer and hair pointer, tortoise pointer one step at a time and hair pointer two steps at a time. So when the both pointers meet, it will definitely be in a cycle. It will definitely be a point in the cycle. So for suppose the tortoise pointer has traversed a total distance of f plus x, f being the distance from the start of the array to the start of cycle, and x being the distance from start of cycle to the intersection point within the cycle. So the hair pointer would have traveled f, it is the distance between start of array to the start of cycle, and a distance of k and c, it means it would have already might have completed k cycles, and a distance of x is the distance from start of the element and start of till the intersection point in the cycle. So since here is traversing twice as speed when we compare with the speed of tortoise pointer, the distance traversed by tortoise pointer f plus x multiplied by 2 will be equal to distance traveled by hare pointer. So if we solve this, we simplify this, so we can say f plus x is k into c. So this equation tells us the distance traveled by tortoise pointer before meeting the hare pointer will be a constant multiple of length of cycle. So now we have derived this equation from the first phase 1 by going to the phase 1. Now in the phase 2, we have let us reset the tortoise pointer to the start of the element and hare pointer, leave hare pointer at the intersection point. And in this phase 2, the tortoise pointer and hare pointer will move one step at a time. So it means that when since we have derived this equation in the while going through the first phase 1, f plus x equals to k plus c. So when tortoise pointer travels a distance f, the hare pointer would have also traverse the distance f. So f is nothing but kc minus x. So the hare pointer would have traversed a distance of kc minus x. So the k pointer is at a distance x in order to complete its kth cycle. So since the hare pointer in phase 2 is starting from the intersection point, so it is at a distance x from the intersection point in order to complete kth cycle. It means that since x is the distance between start of cycle and intersection point, it means that the hare pointer is at entrance point of the cycle. And since the tortoise pointer has traversed a distance of f, it means that the tortoise pointer is also at the entrance point of the cycle. So that being said, that in phase 2, when tortoise pointer and hare pointer is moving one step at a time, both will meet at the entrance point of the cycle. Yeah. So that is that justifies why we are doing phase 2. So that being said, we'll go through the computer program. So we have discussed that first we need to find the intersection point, and then we need to find the entrance point of the cycle. So since while we are traversing through the index as per the value of an element, so the indexes which we have been traversing are repeating in a cycle. So that's why we have used this fast and slow pointers algorithm, and we have used this algorithm to detect the entrance point of the cycle as well. So that being said, let us check the computer program. So this computer program over here is written in Java programming language, which has a method called find duplicate, which takes input as an array of integers. In the phase 1, we start both tortoise and hare pointer from the first element, and we'll start a loop to move the tortoise pointer as per the value at index as per the value of an element, and we'll be moving hare pointer twice as speed as tortoise pointer. And if ever tortoise and hare pointer meet, we'll be stopping, we'll be breaking, and we'll be moving tortoise pointer to the first element and leave hare pointer at the intersection point. And then we'll be starting a loop until the tortoise and hare pointers meet, and we'll be moving the tortoise pointer one step at a time and hare pointer one step at a time. When they both meet, it will be the entrance point. So we'll be returning that um, value. So we can return the tortoise or hare. We'll be returning this here. So this is the duplicate element of the given array. So in this video, we have discussed four approaches in order to solve this problem of finding a duplicate number in a given array. We have checked a brute force approach where we go through all the possible pairs of the given array, and we have checked the approach 2 where we use a hash set, and in the approach 3 where we manipulate the given array elements of the given array in order to store how many times a value of an element at an element has been present in the given array without actually losing the original content of the given array. And at the end, we have solved this problem using a fast and slow pointers technique. Yeah, so that we have gone through these four approaches. So I will leave a link of this sheet which I have been displaying over here in the description of this video. So this sheet has many such problems which can be essentially solved using the fast and slow pointers approach. So feel free to go through it. Yeah, so that's it for this video. See you in the next.